Sarah. This is my concept map. I will close up the camera in a little bit in order to get all of the other little terms that I've written down. But okay, so from this lab, what I've learned is that everything in one way or another is related. For example, I'll begin with the units of measurement. The units of measurement is not directly related to an atom or an element or a molecule, but when you're in for example, a chemistry lab, you're trying to cook up all of these chemicals and you need to, for example, if you're in an organic chemistry lab and you're looking for a ketone, if you're trying to mix certain ingredients to cook up a chemical that will include a ketone, you have to measure them precisely, because if you use one chemical too much or not enough, you might not be able to get the outcome that you desire. So that's why these arrows, although like I stated before, units of measurement is not really directly related to a bond. That's how it is related to all of this. It is in one way or another related to it because all of these things essentially go into a beaker, which units of measurement have to be used in order to correctly mix and cook what you need. And that would all take place in an organic chemistry lab, or a biology lab, or an organic chemistry lab. So the way I organized all of this is basically the bigger umbrella to the smallest umbrella, except for units of measurement, which I left at the bottom, just because, like I stated, it's not directly related to all of this. But other than that, it should go by size and relevance. So for example, although science was not a term that was included, I wanted to go ahead and include it that way. These three would be under that bigger umbrella. So it's science, and then organic chemistry, biology, and inorganic chemistry, biology, and organic chemistry. Right under biology would be cell biology. There's a ton of biologies, so one of them would be cell biology, which is a little bit more specific. And under that, I decided to put these terms, which we are looking at, which are technically under chemistry as well, which is why I put the arrows. And actually, you do see these things more, for example, in an organic chemistry lab, since organic chemistry has all of these carbon-related elements. So, but since we are in a biology class, I wanted to also state that it is related to biology. Because, for example, an atom, we start learning about molecules and atoms and everything in a biology course, and we're first introduced to them, all of these terms, in a biology course. We go in depth when we go into a chemistry course, which brings me to another point. That is also how I arranged all of the smaller terms. I wanted to go ahead and, for example, although nucleus of an atom can relate to a lot of these things, I wanted to go ahead and include it under atom because we first see these terms when we're learning about atoms. And molecules, molarity, it relates to other things here too, but I wanted to go ahead and put it under molecules because we start learning about all of that stuff when we start to learn about molecules. Returning to how they relate. So these two, functional groups and polymers, if you can notice, I put each different one with a different drawing around them, or a different shape. So these three are the same. This one was a little bit more specific, so it's a circle. These two I put together, not necessarily because they're the same size, because polymers are much larger than functional groups, but I wanted to go ahead and put them in the same shape because they're specific types of bonds. So these are all bonds, and so are these. And bonds I put differently because the terms under bonds are not specific bonds, but more or less a description or a type of bond. So I wanted to go ahead and put it under. And these three, for example, an atom. So atom is the smallest unit we have, the smallest little particle that we can think of or that we know so far. So the atom would relate to these in, okay, let's say, so if you wanted a molecule, for example, a water molecule, one of the elements, two of the elements actually, would have to combine to make a molecule. So a hydrogen atom, which hydrogen is one of the elements, a hydrogen atom, two hydrogen atoms, would have to connect with an oxygen atom, which oxygen is also an element, to create a water molecule. So that is just a small little molecule, and then whenever a bunch of other elements combine, then they start forming bonds, and then they start growing. Well, they start forming a specific type of bond, especially if it's hydrogen. One of the bonds is hydrogen bond. Once they become a bigger bond, it'll take one of these types of bonds to make that bigger bond, and it could be either a functional group, which won't be that much bigger, or a polymer, which are pretty big. And monomers, I put a little bit to the side, and that's the same shape as polymers because monomers are the small little units to polymers, kind of like, nucleotides are to nucleic acid. They're just the little elements. So I could have put it somewhere over here where it was smaller, but I wanted to go ahead and leave it over here because it's the essential unit for polymers. And I believe that's it. Thank you for watching. As I stated before, this lab has taught me that in one way or another everything relates, which shows all of these arrows. And the arrows go up and they go down just because if I'm explaining something, like I explained the atom, I can go up, so one atom to an element to a molecule, or I can go down like I explained at the beginning, from chemistry to cell biology to these other terms. And I will close up the camera so you can get a better look and make sure that I have all of my terms. Thank you. Okay, so this is the concept map. Now we'll go ahead and close it up. Thank you.